Hi guys, in this video tutorial we'll see how to build functional reactive programming using Spring Boot 2. So first of all we'll see what is reactive programming. So reactive programming is a programming with asynchronous data streams. This basically improves user experience. We want to make the system more responsive. So this is concerned with data streams and propagation of changes. It is a style of microarchitecture involving intelligent routing and consumption of events. It's all about asynchronous and event-driven applications. The applications where you need the minimum or small number of threads to scale vertically within JVM rather than horizontally through clustering. Now, what is functional reactive programming? So, functional reactive programming is a paradigm for reactive programming using the building blocks of functional programming. You can use map, reduce, filter for building your functional reactive programming. Now, we'll see some of the use cases of reactive programming. So, optimize the complex orchestration of dependencies between service calls. So, it means that you have services which basically calls other services. So, it's basically nested service calls. So, most of them are working on HTTP protocol, and this HTTP protocol by nature is synchronous or blocking. So functional reactive programming or simply reactive programming makes it easier for you to compose the service calls easily. Highly concurrent message consumers in messaging system in enterprise applications. It means that when you have to process millions of messages per second and also the performance matters at that time, your reactive programming comes into the picture. So using reactive programming model, you can easily process millions of messages per seconds, because it is very easy to convert using functional reactive programming from events to message. Developers don't need to worry about coding whether synchronous or asynchronous. So developers don't need to know whether they are coding for asynchronously or synchronously, because by nature functional reactive programming or simply reactive programming is asynchronous program. So reactive programming in Java. So Java itself does not support reactive programming until Java 9 version. But there are a number of libraries you can use in Java, because Java is the powerhouse of developing the enterprise applications. So such libraries are Reactor, Reactive Streams, RxJava, Spring Framework 5, Ratpack, or maybe more. So what is the what is the point of writing of reactive programming? So it is not just all about the technology, but it is about efficiently managing the resources, or how you manage the resources efficiently. So basically, you invest less on your servers and data centers, but you get more. So why we are using Spring Boot? So there are many advantages, like Spring Boot applications are standalone applications. So you just have the main class, and when you run the main class, you don't need to worry about the applications. Application gets deployed in the embedded Tomcat server or any other server like JT, starter, POM or Gradle. So either you can use the starter dependency into POM or Gradle build script. Automatically configurations. So you don't need to like define configurations in some XML files or anything. You just use annotations like enable auto configuration or @configuration. No code generation. You don't need to. No XML. You don't need to use any XML file for this Spring Boot application. You just need to focus on your business logic. Production ready feature matrix. So Spring Boot comes with the built-in APIs like Actuator, using which you can easily check the health of the applications, or you can monitor the application's performance, whether it's up, down, or whether it behaves in expected way or not. So reactive programming in Spring. So Spring internally uses Reactor for the support of reactive programming. We have Spring Web Flux module, using which you can build your reactive programming system or application. So it supports like annotation based support for Spring MVC. You can also do in the functional way using Java 8 Lambda style for handling routing. So Reactor library, there are few concepts like reactive core. So it provides fully non-blocking on-demand functionality and directly interacts with Java 8 functional API, completable feature, stream API and duration. Non-blocking I/O. It is suitable for microservices architecture with support for back pressure ready networks. So networks works on protocol like HTTP including WebSockets, TCP and UDP. It also fully supports encoding and decoding. So reactor types. There are two types of reactors. One is mono, another one is flask. So mono basically returns either 0 or 1 entity, whereas flask returns a list of entities. So when you have to return a single entity or you may not return any entity, then you can use mono. And if you want to return a list of entities, then you can use flask. So here is the example. So when you are finding all entities from your database, then you are using flask. When you are finding single entity from your database, then you are using mono. If you do not want to return anything, then also you can use mono. For example, when you are adding a new website here, demo. So for this demo, you need to add one dependency, that is Spring Boot Starter Web Flask, and we are using Spring Boot version 2 here. So 2.0.3. We have applied some plugins. This is for Gradle file. So this is basically CRUD repository. So you are defining these methods for your CRUD operations. You are fetching all websites, you are fetching single website, you are deleting existing website, you are adding new website, you are updating existing website. And accordingly, you are returning the response, either mono or flask. This is handler function. This handler functions basically handles the incoming HTTP requests from the client. So it takes basically server request input and it returns response with mono server response. So you can see the example how we are building the response, server response, and how we are extracting the information from the server request parameter. This is the router function which is required for routing your incoming HTTP requests through your handler function. So basically here we are using request predicates to form our URIs to return our MIME type or media type, what type of data we want to return to the client. And you can also see that from our handler we are referring the appropriate function through this router. So this was just a snapshot of the full example. So you can visit the full example available at my blog here. Thank you guys for watching my video.